Howdy! In this video we're going to take a look at a couple of word problems. In this number 11 we see the longest zip line in the world is the Zip Rider at Icy Strait Point, Alaska. Its length of the zip line is 5,495 feet and has a vertical drop of 1,320. So you can imagine a zip line starts at a high point and ends at a low point. Now, I'm going to shrink it up just to give us some room to work. But it says its length is 5,495 feet and it has a vertical drop of 1,320 feet. 1,320 feet. Now, I'm leaving the length off for now because I think we all agree on that. Here's where it gets tricky. Where does that length go? Some people want to put that length down here. Some people put the length here. It's important that we're consistent. Since it says, which one do you think it is? Think about it for a second. Pause it if you need to. Since it says the length of the zip line, I think the best way to interpret it is this distance right here. So if you're a rider on the zip line, you're going to go from here to here, and that's the length of the zip line. I would call this the horizontal distance, or the horizontal distance along the ground. So we are going to put 5,495 feet here. It's now asking us to find the angle of depression. Where is the angle of depression at? Well, imagine you're up here at the top, thinking about the horizon, sticking your arm out, and then looking down. This is the angle of depression. This is what they want us to find. There's a couple ways of doing this. I think I'll do this first by finding this angle here. I'll call this angle alpha. Would you agree if I found alpha that you could then find theta? Just take 90 degrees here, minus alpha gives you theta. So let's go ahead and find alpha first. We've got alpha, we've got this side and this side. So if we think of alpha as my angle, this is definitely the hypotenuse. What's this side? This side is adjacent. So we get the cosine of alpha equals adjacent 1320 over the hypotenuse. I don't know why I wrote hypotenuse, which is 5,495. To find alpha, we need to do the inverse cosine of each side. So alpha then is the inverse cosine of 1320 over 5495. When we type that in the calculator, we get 76.1 degrees. So we know alpha, 76.1 degrees. To find theta then, we just got to take 90 degrees minus that, because this is a right angle here, and that gives us 13.9 degrees. So the angle of depression is 13.9 degrees. Now, there is one little kind of shortcut or trick that I want to show you. It's fine. This strategy here was fine that I did. If you want, I want to point out that we can think of this as two parallel lines. This base of the triangle and this horizon are parallel. And when we have two parallel lines, there's a theorem in geometry that says alternate interior angles are congruent. So this angle down here is actually the same as this angle up here. And so we can find the angle of depression instead of using alpha and looking at that as the adjacent side. We can use theta and think of that as the opposite side. Hypotenuse is still the same. In this case, we just set up sine theta equals opposite, which is 1320, over hypotenuse, which is 5495. And if you solve that, you'll see you'll get theta is 13.9 degrees. Pretty cool, huh? All right, another problem here. I can just hear your enthusiasm through the video. All right, an indoor ski resort. It's pretty impressive. I've never actually skied in my entire life. I would like to someday. Here we go. It's an indoor ski resort. Its longest ski run drops 60 feet and has an angle of depression of approximately 8.6 degrees. Find the length of the ski run. So you can imagine a ski run. We've got a little skier up here. He's skiing down the slope. Okay, and again, I'm going to shrink it up just to give us a little more room. It drops 60 feet and has an angle of depression of approximately 8.6 degrees. So the angle of depression here is 8.6 degrees. It drops 60 feet. Feet, and it asks us for the length of the ski run. Okay, this is the same question we had earlier. What is the length of the ski run? If you're the skier, I would say this is the length of the ski run here, L, or I might call it the hypotenuse because that's the hypotenuse, no matter what angle we pick. So if this is 8.6, we've got the hypotenuse, we've got 60 feet. How are we going to do this problem? You could use a little trick I showed you up here if you want, or you can just take 90 minus the 8.6, because you know this is a 90-degree angle. And when you do that, 90 minus 8.6 is going to give you 81.4 degrees. If we use the 81.4 degrees, what is this? Is it adjacent? Is it opposite? Hopefully you're comfortable with that being adjacent. And if I have adjacent and hypotenuse, then I know I need to use cosine of 81.4 degrees equals the adjacent side over the hypotenuse. Cross multiply and divide. We're going to get x equals 60 divided by cosine. Let me show you that. I'm doing too much work in my head. X times cosine of 81.4 equals 60. Divide both sides by cosine of 81.4. Again, if you want to put the decimal in, you can. And then that shows you that x equals 60 divided by cosine of 81.4. So we now get, type that in our calculator, we get 401.2. And this is feet. So the indoor ski run is a 401.2 feet. So really the key ideas here for these story problems is draw your picture. That's huge. Make sure you get your information in the right place. The length of the run or the length of the zip line versus the horizontal distance. Identify what angle you're going to work with. Identify the names of the sides. This was originally adjacent. Tells you which trig function to use. Set up your equation and solve. Suppose you could make that a list of steps if you want. Draw a picture. Identify angle. Set up. Identify sides. Choose your trig function. Set up your equation and solve.